Welcome to Succeed e-learning app. In this video, let us study about carbon and its compounds. Let us learn about carbon. Carbon is of immense significance to us in both elemental and compound form. Food, books, medicines, all of this is based on carbon. Even though the percentage of carbon on Earth's crust or atmosphere is very less, it is of great importance to us. Now let us see some of the basic properties of carbon. Bonding in carbon. Do you know what is the electronic configuration of carbon? Do you know what is the valency of carbon? Yes, the atomic number of carbon is 6, and we can see that the outermost shell contains 4 electrons. So, we say that it is tetravalent or valency is 4. The electronic configuration of carbon looks something like this. In nature, every element tries to attain noble gas configuration. Similarly, even carbon tries to attain noble gas configuration. This may happen in two ways. 1. It can gain 4 electrons and become C4 minus anion. But this is not possible because 6 protons of carbon has to hold 10 electrons around it, which is unstable. Thus, this is not possible. The second way is it can lose the 4 electrons and become C4 plus cation. This is also unstable and it requires large amount of energy to remove 4 electrons from the outermost shell. To overcome this problem, carbon shares its 4 electrons with other monovalent atoms or other carbon atoms. Let us take an example. Let us take an example of methane. Methane something looks like this. The chemical formula of methane is CH4, that is, carbon shares its 4 electrons with 4 different hydrogen atoms and valency of hydrogen is 1. So, 4 different hydrogen combine with 4 different electrons around carbon to get CH4. The bond formed by sharing of electrons is called a covalent bond. The covalent molecules have strong bonds, but they have weak intermolecular forces, which give rise to low melting and low boiling points. Since there is no exchange of charges or electrons, they are electrically neutral, that is, they are poor conductors. Let us see some examples. Hydrogen molecule has a single covalent bond. Oxygen molecule has a double covalent bond, and nitrogen molecule has a triple covalent bond. After seeing the bonds in hydrogen, oxygen and nitrogen, let us come back to carbon. Versatile nature of carbon. Versatile meaning adaptable. There are millions of carbon compounds. As seen in the beginning, all the things around us are based on carbon. So, what property of this carbon makes it more versatile or different from other elements? Yes, the two main important properties are catenation and tetravalency. Now, let us see at each one of them. Catenation. Carbon bonds with other carbon atoms to form large number of molecules. This property of carbon is called catenation. It may be in straight line, branched or even arranged in rings. In catenation, the carbon atoms can be linked by a single, a double or a triple bond. The carbon-carbon bond is really strong and stable. No other element exhibits the catenation to the extent seen in carbon. Tetravalency. Carbon has valency 4. This means carbon can bond with 4 other carbon atoms or 4 other monovalent atoms. Carbon bonds with other carbon atoms, hydrogen, chlorine and other monovalent elements. These bonds are stronger due to small size of carbon, and thus the nucleus holds the electrons much stronger in small size atoms. Now let us try to classify carbon compounds. We know carbon forms single, double and triple bonds between carbon atoms. Based on the type of bonds, carbon compounds are classified as saturated and unsaturated hydrocarbons. Now what are hydrocarbons? Hydrocarbons are carbon compounds which contain only carbon and hydrogen. Saturated hydrocarbons. Carbon compounds containing single bond between carbon-carbon atom are called saturated hydrocarbons. When there is a single bond present in carbon compound, they are called alkanes. They satisfy the general formula CnH2n plus 2. They are quite less reactive when compared to unsaturated hydrocarbons. Unsaturated hydrocarbons. The carbon atoms or compounds containing a double or a triple bond between carbon-carbon atom are called unsaturated hydrocarbons. They are more reactive when compared to saturated hydrocarbons. When there is a double bond between a carbon-carbon atom, they are called as alkenes, and they satisfy the general formula CnH2n. Now let us see what about third bond. When the carbon-carbon atom has a triple bond between them, they are called alkynes, and they satisfy the general formula CnH2n minus 2. In all these cases, N stands for number of carbon atoms present in the compound. Now let us see the structure of carbon atoms containing more than one carbon atom. Let us look into this table. Methane, one carbon atom, CH4, and the structure is 2 carbon atoms, ethane, C3H6 and the structure 3 carbon atoms, propane, C3H8 and the structure 4 carbon atoms, butane, C4H10 and the structure 5 carbon atoms, pentane, C5H12, the structure 6 carbon atoms, hexane, C6H14, the structure. Let us take up the example butane, C4H10. This compound can be drawn in two different ways, the straight one and the branched one. These two carry the same formula C4H10, but they are structurally different. These kind of compounds are called structural isomers. Carbon can also be placed in rings, example cyclohexane and benzene. Functional groups. Carbon forms bonds with hydrogen, oxygen, halogens and sulfur. Carbons bond with these elements so that their valency is satisfied. In hydrocarbons, the hydrogen can be replaced by these elements. They are called heteroatoms. Heteroatoms provide a specific property to these hydrocarbons. Now let us see some of the functional groups. The functional group, halogens. The compounds are chlorine and bromine. The functional group is represented as Cl and Br. The heteroatom is oxygen. Then the compounds are alcohol represented by OH, aldehyde represented by CHO, ketone represented by C double bond O, and carboxylic acid represented by COOH. Homologous series. We know that the hydrogen atom can be replaced by a functional group called heteroatoms. These heteroatoms provide a specific property to the carbon chain, irrespective of the length of the chain. Let us take an example: CH3OH, C2H5OH and C3H7OH. All these compounds are alcoholic, that is, they have same property irrespective of length of the carbon atom. Let us move on. Let us take another example. Methane and ethane differ by a CH2 unit. Ethane and propane differ by a CH2 unit again. So, we can say that methane to propane, propane to butane, all these things are in homologous series. Such series of compounds in which the functional group is replaced by hydrogen atom in a carbon chain are called homologous series. Now, let us learn how to name the compounds. Nomenclature. There are many carbon compounds around us. Let us try to name each one of them using simple rules. Let us look into the rules. Based on number of carbon atoms, the root words are named. If there is one carbon atom, we use meth. 2 carbon atoms, eth. 3 carbon atoms, prop. 4 carbon atoms, bute. 5 carbon atoms, pent. 6 carbon atoms, hex, and so on. And if there is a functional group present in the carbon chain, we use a suffix or a prefix. If the suffix of the functional group starts with an vowel, then we emit O and write its name. Let us take an example. Let us take 3-chained carbon atom and a functional group ketone. Since the functional group is ketone, its suffix is ONE. Since O is an vowel, we omit E from propane and write it as propanone. Now, let us try to apply these rules and name some compounds containing the functional groups. For ease, let us take a carbon chain containing 3 carbon atoms. Now, if the class of compounds are halogens, then we use a prefix chloro or bromo, whether it is chlorine or bromine, and the name is chloropropane or bromopropane. If the functional group is a ketone, then we use propanone. The suffix is ONE. If the functional group is alcohol, then the suffix OL, propanol. If the functional group is aldehyde, we use AL, that is propanol. If the functional group is carboxylic acid, we use oic acid, propanoic acid. If there is a double bond in the carbon chain, we use ENE, that is propene. If the carbon atom contains a triple bond, then we use YNE, called propyne. Hope you saw all the functional groups and their nomenclature. Let us look at some of the chemical properties of carbon, starting with combustion. When carbon is burnt in presence of oxygen, it is converted into carbon dioxide along with heat and light. It follows this reaction. Now, when hydrocarbons are burnt in presence of oxygen, we get the products as carbon dioxide and water along with heat and light. All the compounds like gas, kerosene, coal and petroleum, all these on combustion produces similar products. Now let us move on to oxidation. Aren't all combustion reactions oxidation reactions? Yes, all combustion reactions are oxidation reaction. Now let us try to oxidize alcohols. Alcohols in presence of oxidizing agents like potassium permanganate and potassium dichromate produces carboxylic acids. Let us take an example. Ethanol in presence of potassium permanganate or potassium dichromate produces ethanoic acid or acetic acid. Addition reaction. Addition of hydrogen to unsaturated hydrocarbons gives saturated hydrocarbons. This happens in presence of a catalyst. Now what is a catalyst? Catalyst is a substance which helps the reaction to occur, or it determines the rate of the reaction. Let us take an example. Unsaturated hydrocarbon. Addition of hydrogen in presence of a catalyst, nickel or palladium, we get saturated hydrocarbon. Now let us move on. Substitution reaction. Saturated hydrocarbons in presence of sunlight react with chlorine. In this reaction, chlorine is replaced by hydrogen's atom. Since replacement is taking place, we call it as substitution reaction. Example. Here, if there is large amount of chlorine, then all the chlorine atoms are substituted by hydrogen atoms and we get tetrachloroethane. Example for substitution reaction. In this example, if chlorine is more, then all the hydrogen atoms are substituted and we get tetrachloromethane. Let us look at some of the important carbon compounds. Ethanol. Ethanol is an alcohol. At room temperature, it is liquid. Ethanol is a good solvent in water. Thus, we use it in many medicines such as cough syrups and tonics. Now, let us see ethanol reaction with sodium. Generally, when alcohols react with sodium, hydrogen is liberated. Similarly, ethanol reacting with sodium, we get ethanoxide. The reaction is. Now let us see another type of reaction. When alcohols are burnt or heated in presence of sulfuric acid, we get saturated hydrocarbons. Let us take the example. Ethanol heating in presence of sulfuric acid, we get ethane plus hydrogen. This is dehydration reaction because hydrogen is liberated and sulfuric acid acts as a dehydrating agent. The equation is. Now let us see to another example or important compound, ethanoic acid. Ethanoic acid is a carboxylic acid, but they are weak acids when compared to mineral acids such as HCl and H2SO4. Ethanoic acid is also called as acetic acid. Acetic acid in water, 5 to 8% is called vinegar, and vinegar is used as a preservative in food industries. Now let us see reactions with ethanoic acid. Esterification. When alcohols react with carboxylic acid, we get esters. When ethanol is reacted with ethanoic acid, we get ester. Esters are sweet substances. They are used in perfumes and as sweetening agents. Esterification. When acid reacts with alcohol, we get esters. When ethanoic acid reacts with ethanol, we get an ester. The equation is. Esters are also used in preparation of soap. This process is called saponification. When ethanoic acid reacts with a base. Just as any acid, even carboxylic acid react with a base to give a salt and water. Ethanoic acid reacting with NaOH will give sodium acetate, and the equation is ethanoic acid reacting with hydrogen carbonates and carbonates. On reaction with ethanoic acid, carbonates and hydrocarbonates, we get sodium acetate and carbon dioxide along with water. Now let us see what are soaps and detergents. Generally, dirt is oily in nature, and we know that oil does not dissolve in water, so it becomes hard to remove with water. So we use substances called as soaps. Soaps are sodium and potassium salts of carboxylic acids. The sodium part reacts with water, whereas the carbon end reacts with the oil, and they form a structure. These structures look something similar to this. These structures are called micelles. In micelles, the center part is the oil and it is surrounded by the carbon atoms. It reacts with the oil. The sodium part reacts with the water. And this is how the dirt is removed in clothes. Soaps doesn't produce lather with hard water. That is, soaps reacts with magnesium and calcium salts. So we require large amount of soap to clean a substance. Thus we use something called as detergents. Detergents are sodium salts of sulfonic acids. In detergents, the products doesn't react with magnesium or calcium ions in water. Thus, it can be used as a cleansing agent. Detergents are used in shampoos and other cleaning agents. To summarize and conclude this chapter, let us see what we have learnt. We learned the versatile nature of carbon. We learned two important properties, catenation and tetravalency. We learnt about covalent bonding, alkanes, alkenes and alkynes. Then we saw different functional group, their nomenclature and their properties. Then we saw two important compounds, ethanol and ethanoic acid. Then we learnt what are soaps and detergents. Hope it was interesting. Please keep watching Succeed e-learning app.